You should be able to see this pretty good. I've got one more 3x3 system for you here. I will go through it just the same way that we always do with the colors and the highlight and all of that good stuff. Let's switch that to red so we can start there. We are going to do it by substitution, which means we want to, let me fix this Z while we're here. We want to start with one of them. Much better. Start with one of them being solved for a variable. As you can see on that top one, we've got quite a lot of variables to choose from. Personally, I'm going to just pick X because it's the first one, it's the top one, it's the one we're most familiar with. So if I wanted to solve X plus Y plus Z equals 0 for a variable, I want to solve it for X, I want to move the Y to the other side. Now, I don't need to say 0 minus y. That's not something we do in math. I can just say minus y. I'm going to move the z to the other side as well, doing the same thing, just kind of tacking it on the end to give us an x equals negative y minus z, which is perfect. I'm just going to move it up a little bit. That does give us something to plug in to the other two things. So we can take our second equation and we can plug that whole thing in for x, negative y minus z, plus 2y minus 4z equals 12. That would be your entire second equation with the first one plugged into it. So you do want to distribute. You want to distribute the negative 2 to the negative y, giving you 2y, and the negative 2 to the negative z, giving you plus 2z. And since we have not touched everything else, we're just going to bring them down. For our next step, we can then combine any like terms that we have. I have a 2y here and a 2y here, giving me 4y, a 2z and a minus 4z, giving me negative 2z, and that whole thing still equals 12. What that gives us is a equation that has two variables that we can use in a 2x2 system. So we can then go back and do that same exact thing that we just did, except we're going to do it with the third equation this time. So we're going to plug in all of that stuff for x down here, negative y minus z, minus 3y minus z equals 7. Same thing, we can distribute the 2 this time. 2 to negative y is a negative 2y, negative 2z, and we bring everybody else back down to the party. Combining any like terms that I have negative 5y, I have minus 3z equals 7. That gives me a second equation with two variables, the same two variables that I have up in the first green equation up at the top there. I can then go in and solve those. Let's do it in this strange orange color. I can then take those, my 4y minus 2z equals 12. Can you see that orange? Yes. Let's do a darker color. We can see 4y minus 2z equals 12. That's a much better color. And negative 5y minus 3z equals 7. If we're going to continue with substitution, and I'm going to just so that you guys can see what's going on, this top equation could be quite nicely solved for z. we could take 4y minus 2z equals 12 and just kind of rearrange it a little bit. We can move the 4y to the other side, giving me a negative 2z equals negative 4y plus 12. And what that will do for me is give me the chance to then kind of look at this and go, I can divide everybody by negative 2. Gives me z, 2y minus 6. Well, Miss Burke, that's just another equation to plug in. We haven't actually solved for anything. And you're right, we haven't. But now I can substitute this equation in over here to find out what z is going to be. Minus 3, 2y minus 6 equals 7. Carry down the things we know and distribute what we don't. Negative 3 times 2 is negative 6y plus 18 equals 7. That's a negative 11y equals, oops, not equals, we didn't move that 18 yet. You guys, some of you might skip some steps and move the 18 already because you do know what's going to happen. And you could. I just do it the long way so you guys can see. Negative 11y, moving that 18 over gives me a negative 11. And y is going to equal 1. Well, that's one thing that we know. We now know one of our pieces. And if you remember when we did 2 by 2 systems, what we did then is plug that back in to the other equation, into this bad boy down here. So we can do just that. I can say z is going to equal 2 times whatever y is 1, minus 6. Well, 2 times 1 is 2, minus 6 equals negative 4. So now I know that z equals negative 4, and we are, in fact, almost done. We are at that point now where I will zoom this boy back out so we can see our original equations up in the space over here. I'm going to write down what we know. We know that y equals 1. We know that z equals negative 4. I don't yet know what x equals, but I can use these two pieces into my first original equation over here. It's set up quite nicely where it's got no coefficients. It's equal to 0. I can just say x plus y plus z equals 0. And I know I don't know x yet. We'll leave it as an x. I know that y is 1. I know that z is negative 4. X minus 3 equals 0. X equals 3. That gives me the point now where I now have all 3 of my pieces. I can come here and say that my solution is 3, 1, and negative 4. Don't forget, you also could write it out like this if you preferred. Both of those are valid ways to say what your solution is. And that's it. That is 3 by 3 systems with substitution. If you have any questions, let me know.